guys, welcome back. Go for your pen, go for your paper, go for your math textbook. We're ready to do some math. So today's topic, we're going to look at vectors and matrices. So multiple choice questions. We're going to look at these 40 of them. I think I have 40 questions there. So let's see how fast we can run through 40 questions, multiple choice. Vectors and matrices, talking about concepts like magnitude of vectors, parallel, equal. We're going to look at calculating the adjoint, the determinant. Yes, laugh at Mr. Sherin. So let's go to our first question. Says, so in the diagram OP, no, what we call questions, what we call these, we call any vector that starts at the origin O, we call it a position vector. And position vectors can be written as column vector xy. Now the x tells our horizontal movement, right? So if we go to the left, it's negative, and if we go to the right, it's positive. Our y tells us our vertical movement. So if we're moving up, it's positive, and if we're moving down, it's negative. Now in the diagram above, OP is 5 places to the left, so 5 places to the left is -5, and 9 places down means -9. So our answer is B. Question 2, in the diagram above, OQ. So the same concept, so OQ is also a position vector because it starts from the origin. Now the vector of horizontal movement is what? 3 places to the left, so that's -3, that's our x, and then we have 8 places up. 8 places up, so that's +8. So OQ, the vector OQ is going to be -3, 8, and that matches with B. Ignore the background sound here, so you go. Question 3. If P is the point XY, just a notation here. If P is the point XY, so OP, which is the same thing XY. Now what this saying, if we get the point, so we get a point 4, 7 here. This point can be written as a column vector OP XY. So therefore this represents our x, the 4, and the 7 represents our y. So therefore OP is going to be 4, 7, and that matches D. So once I get the point, all points are written in the form x then y. The position vector of that point is xy. Just writing it in a column vector format. Alright, question 4, the same concept. So in this case, we have a position vector OQ where it goes 5 places to the left, that's -5, and 10 places up, that's +10. So OQ is going to give us column vector style. We get -5, +10, and that matches to C. C, with some weird saying she, C, whatever. Alright, question 5. Alright, the magnitude of a position vector OA is -5, 8. Now, how do we find the magnitude of a position vector? Now, there's a particular formula that we follow. So, the magnitude of a position vector, and we use these little bars here to symbolize finding the magnitude of a vector. So, that's going to be the square root of, what's our x value? -5, so -5 square plus 8 square. Now -5 squared, so we have the square root also. You just follow this formula. Basic. I'm trying to go fast. I don't want this video to be very long at all. I'm trying to think. Let me see what can happen by the end of it. So we have -5 squared, that's 25. And then we have 8 squared, that's 64. So 64, so we have that gives us the square root of 89. So therefore the magnitude of OA is square root 89. I will leave our answer as square root. Now you go ahead. Remember me said this is not expected a sport, so you have to get involved. And next magnitude, what's the formula again? Tell me the formula. We can't hear you. Say it again. The formula is? Alright, so now that the formula to find the magnitude of a position vector is, I still can't hear you, know. Alright, good. So let's go ahead and work it out now. So we have the square root, so which is the square root of, we're gonna have 4 square plus negative 9 square. So 4 square is 16 and negative 9 square is 81. So we can add that now, so we get the square root of 97. So the magnitude of the position vector OB is the square root 97. Alright, next question. Now, looking at our some heap of terms here, so before we even start with the question, the answers are standing on equal and parallel, perpendicular, and unit vectors. Now, in order to answer this question, you have to know what are these concepts. So let's read the question first. If A is 4, negative 2, and B is 16, negative 8, then the two vectors are equal vectors, parallel vectors, perpendicular vectors, unit vectors. Now remember, these lessons are not substitutions for your actual class. Keep going to class and keep learning from your teachers. Alright, so let's look at it. If two vectors are equal, they have the same magnitude and direction. Parallel vectors have the same direction or exact opposite direction. Two vectors are perpendicular when their dot product is equal to 0. And a unit vector has a magnitude of 1. Now we don't know if I find magnitude already of vectors, because we looked at the parallel, we looked at finding the magnitude of a position vector. And a displacement vector is a slight different, but it's the same thing in essence. Alright, so let's look at it now. Which one would match? Would it be an equal vector? Alright, so two vectors are equal, they have the same magnitude and direction. So we're going to have to work out the magnitude. But by common sense, we look at it, if we find the square root of 4, or square 4, or square 2, and then find the square root. Equal wouldn't match for us. I look at parallel and not parallel. Another way of proving if vectors are parallel is if they are a scale factor of the other. What do we mean by that? So for example, if I have 2, 4, and then I have 8, and let's say 16, you observe that I multiplied 2 by 4 gives me 8, and then 4 by 4 gives me 16. So the scale factor here, or the scalar that they would share, would be positive 4. Now because this 8, 16 is 4 times the size of 2, 4, then we could say that because they have a scalar relationship, then we can assume, or we can easily say that they are parallel. Now, quick giveaway. What number, what scale factor? Now hold on, note briefly and note pantily. That it doesn't have to be a whole number. It can be positive numbers, it can be negative numbers, and it can also be fractional numbers, both positive and negative. Yes, laugh at me. You know, probably need some speech therapy. Waiting when I grow up. Anyway, so what number could I multiply 4 negative 2 by to get 16 negative 18? Oh look, it's the same 4. Now if I'm 4 times 4, 16. 4 times negative 2 gives me negative 8. So because they have a scalar relationship, then it is fair to assume that they are parallel. So once they have a scalar relationship, they are parallel. So therefore they are going in the same direction. Just that B is 4 times bigger than A, but they're going in the same direction. Alright, let's look at the next one. Alright, let's look at 8. If P is equal to negative 18, negative 24, and Q is negative 3, negative 4, then the vectors are, you tell me now. Let's look through the common concepts. So are they equal? Are they parallel? Are they perpendicular to each other? And are they unit vectors? Yes, Mr. Marine. I'm fighting not to stutter. Anyway, which one fits? Now, do they have a scalar relationship? Well, if you're familiar or comfortable with your timetable, automatically you will realize if you multiply this by 6, you get back negative 18, negative 24. That means if I am to multiply this by 1 over 6, I'm going to get negative 3, negative 4. So they do have a scalar relationship. And once they have a scalar relationship, then we know that they are parallel vectors. Remember, parallel vectors have a scalar relationship. So do collinear and all the others. But we'll get to those we'll get to those in another video. I mean, this is just me stuttering, so me talk by now. Must get used to it by now. Alright, question 9. If P is equal to negative 5, 7 and Q is equal to negative open bracket 5, 7, then the two vectors are, let's look at them. What are they? Are they equal? They have the same magnitude and direction? Are they parallel or non-parallel? Are they perpendicular or are they unit vectors? Still not editor, so it's some teeth sometimes. Some can sound a bit confusing because of how I speak. But when I grow up, I want to sound better. Let's edit that part out. Alright, let's try our next one. Let's look at question 9. So it says if P is equal to negative 5, negative 7, and Q is equal to negative 5, 7, then two vectors are, and let's go back to our terms, equal vectors have the same magnitude and direction. We know that parallel vectors have the same direction or exact opposite direction. Two vectors are perpendicular when their dot product is equal to 0, and a unit vector has a magnitude of 1. Now let's distribute this negative 1, this negative here, or negative 1, same thing. If I distribute negative in the brackets, I have P is equal to negative 5, negative 7. If I distribute this negative here, I have Q is equal to negative 5 and negative 7. And what do you know? We have two vectors that have the same exact thing. Therefore, if we were to find the magnitude and direction, then they would have the same magnitude and direction. So hence, easy to see. What did I just say? I don't know. A, they are equal vectors. Let's look at the next one. Number 10. Now, if R is equal to negative 6, 8, and S is equal to negative 6, negative 8, then the two vectors are, first and foremost, let's distribute this negative sign. So we have R is equal to negative 6, 8. If I distribute this negative sign, I'm going to get negative 6, and negative 10 to negative gives us positive, so we get positive 8. So S is equal to negative 6, 8. So hence, ding ding ding, the two vectors are equal, because if we were to calculate the magnitude and the direction, they will have the same thing. So hence our answer is going to be C, because they are equal vectors. How far you read? How much you get right so far? All 10? 2 out of the 10? 3 out of the 10? What me sound bad? 3 out of 10? 4? 5? All 10? Alright, let's continue. Question 11 now says, if M is 6, negative 9 and N is equal to negative 6, 9, then the two vectors are, now in this question it's an obvious giveaway because I did not put in the transition here, but there's a new terminology, and we have inverse vector. So inverse of a vector is a vector of equal magnitude in opposite direction. So for example, the inverse of A is negative A. And if we look at for example, we have M, look at this. If we have M here, so we have M is 6, negative 9. Now if I multiply negative M will give us negative 6, positive 9. And what does that look like? That looks like N. So automatically we have what is called an inverse vector. Alright? Let's look at the next one. So we say the inverse of a vector is a vector of equal magnitude but opposite direction. That means that if we were to work out the magnitude of this, we get the same magnitude but they are going in different directions. Alright? Let's try our next one. And the obvious thing to help you remember inverse vector is that the inverse of vector A is negative A. So therefore whatever vector you have, you multiply it by a negative scalar, you get its inverse. So let's look at question 12. Now you tell me the answer for question 12. If R is negative 6, 7 and S is negative 6, 7, then the two vectors are what? Tell me, I'm waiting. No man, think again. Tell me the right answer this time. Do you see the right answer? Dora. Anyway, I feel idle. But anyway, so then we realize that we have negative 6, we have negative 6, 7, and we have the same negative 6, 7 here. So this is just saying A and minus A. See the difference? See? So hence they are inverse vectors. Alright, so two vectors are equal. I'm just giving you about the same notes as always. But we're using up the inverse vector concept this time. Alright, question 13. Easy peasy. Now please people, don't go exam and get these wrong. I understand if you mix up the inverse and the parallel and the equal and the perpendicular and all. But please, adding these two basic vectors, just basic addition and subtraction from grade 1 and grade 2. Don't mix it up. Alright, so we have A plus B. So we have A is negative 6, 9, that's our A, and B is 4, negative 5. Now we're going to add our x values, so x values and x values to give us our x values. So negative 6 plus 4 gives us negative 2, and 9 plus negative 5 gives us positive 4. So our answer is going to be negative 2, 4. So A would be our answer. Let's look at number 14. Easy peasy. Make sure you're able to manipulate your directed numbers or your negative numbers easily. Alright, let's look at this. So we have P is equal to negative 10, negative 13, and you're going to subtract Q, which is negative 4, 7. Now, remember, so let's work out the x part. So the x part is going to be negative 10 minus negative 4, and the y part is going to be negative 13 minus 7. Now negative 10, this minus negative 4 become plus, so we have what? Negative 10 plus 4 gives us negative 6. Did I add correctly? Tell me in the comment section if you make no mistake, because I'm not the author and finisher of mathematics, and I'm going to make lots of mistakes because I'm human. Alright, and then we have negative 13 and negative 7, that gives us negative 20. But you see, because of multiple choice, errors are detrimental. Error can cost you your score. So hence our answer is going to be A. So negative 6, negative 20. Alright, let's look at the number 15. Alright, so now we have some scalars working with. So if A is equal to negative 4, 5, and B is equal to 2, negative 3, then 3 times A, so 3 times negative 4, 5, plus 2 times B, which is 2, negative 3. So let's multiply the scalar. So 3 times negative 4 is negative 12, and 3 5s 15, plus 2 times 2, that gives us 4, and 2 times negative 3, that gives us negative 6. So let's go ahead now. So negative 12 plus 4 gives us that negative 8. Yeah, negative 8. And then 15 plus negative 6, that gives us positive 9. So that my brain just take long to add that. No, subtract that. Easy peasy, but we don't know what happens. Sometimes it happens. So we have negative 8, positive 9. So we're looking for negative 8, positive 9. So our answer matches to B. There are times that I work out the correct thing and I have the correct thing in my mind and I circle the incorrect answer. For those questions, I saw persons point out one of them. That to me, that I'm very sorry about those. Alright. Question 16. Let's look at question 16. Same concept from question 15. So look back how we work question 15. Alright, and apply the same concept to question 16. Your time now. Remember me say, go for your book, go for your pencil. This is not a spectator sport. You're not going to do well in math if you sit down and stare at the screen. Alright? Go for your pen, go for your paper and try a thing. Yeah man, I forget it wrong. So I go. Making errors a part of learning too. We nobody's a perfect being out here. So you go for your book, go for your pen, get working. And next thing too, look at secret on the side. Learn your timetable. Alright, let's look at this now. So we have 4p minus 2q. So p is equal to 27. So 4 times 27 minus 2 times q, and that's 6, 5. So 2 4s, 8, and 7 4s, 28. Yes, you see what I mean? Alright. And 2 times 6 is 12. And 2 times, or sorry, let's do it like this. Because it's negative, let's distribute it. Let's distribute it and say plus negative 2, yes, plus. Yes, I just said plus. So negative 2 times 6 gives us negative 12. And then we can say what? Negative 2 times 5 gives us negative 10. So then we're going to have 8 plus negative 12, same thing as saying 8 minus 12, which gives us negative 4, and 28 minus 10, which gives us positive 18. So our answer is going to be negative 4, positive 18, and that matches to B. Alright, let's look at number 7. So the position vector of a point with coordinates P is OP. Now, what the question is asking you for is to write the point as a column vector, and we know this from earlier on from previous question. The first question, that once you're given the point, the first numbers are x and the second numbers are y. So in column vector form, we're going to get negative 8, 15 down. So which one matches with that? That matches with B. So if you're given the point, each point can be written as a column vector x, y. Now let's look at number 18. I know I'm going a bit fast, but you can always slow down the video. I don't know what I'm going to sound like. Slow down. Don't try. Horrible. Alright, question 18. The position vector of a point with coordinates q, negative 7, negative 12 is OQ. Now the same thing we say again. Represent your point as a column vector xy. So this is my x, this is my y. So the column vector OQ is going to give us negative 7, negative 12. And that matches to, oh, look at the answer right here at A. Question 19. Alright. We're looking at magnitude of a displacement vector. Now, before we spoke about the magnitude of a position vector, and now we're going to talk about the magnitude of a displacement vector. Now, they are roughly the same thing in this case, because we don't really have much variables working with here. However, the formula to find the magnitude of a displacement vector, the square root of, and anybody watch any one of my coordinate geometry videos realize that that's just the distance of AB. The formula, the length of the line AB, the magnitude of AB. Alright, so we have x2 minus x1 square plus y2 minus y1. Now in this case, we only have one x and one y, so in this case it's going to work out just as how we did the position vector. So the displacement vector, the magnitude of the displacement vector AB is the square root of 5 square plus negative 8 square. And these are revision videos, so I might be going a bit fast, yes I know, but it's the same concept I'm doing over and over and over and over again, so you'll see. I'll try to slow down. I'm trying to work on the time. I think when the videos are too long, yeah, after 1 hour it can get a bit tiresome. Anyway, I'm talking about the time too. Then this 5 square is 25 and 8 square is 64, so we're getting the square root of 89, so our answer is D. Alright, you try this one for me now, number 20. Yeah man, your time now, your time. Tell me when you get, I'm waiting on you. Yeah man, so first thing you do, we know our formula. Same one from the position vector. Yes. So you say what? PQ. You tell me what to write. So you say, alright, right, there's a sign that. I'm going to put the square root sign, put the square root sign. It's a negative 7 square, beautiful. Plus 3 square, beautiful. Alright. So what is negative 7 square? 7 49. Alright, so we have 49, square root of 49. Plus, what is 3 square? 9. Good. I'm happy nobody said 6. Good. So now 49 plus 9, so 2 9s, 18, carry 1 to the square root of 58. Beautiful. So our answer matches to D. We have matches. I don't know matches, whatever. Alright, question 21. Let's look at that one. We have entered the matrix. Alright, so if matrix A is 3, negative 5, 3, negative 5, 2, 6, and matrix B is negative 7, 0, 4, negative 2, then A plus B is. Now the first thing we can do, We can only add or subtract matrices that have the same amount of columns and the same amount of rows. We can only add or subtract matrices that have the same amount of columns and the same amount of rows. Alright? So we're going to have A plus B. Let's write out A. So A is 3, 5, 3 negative 5, negative 2, 6, plus negative 7, 4, 0, negative 5. Now let's go ahead. Now in order to get, we have to get a 2 by 2 matrix because we're adding two 2 by 2 matrix. Now how we get that word 2 by 2? Because our matrix has 2 rows and 2 columns. 2 rows and 2 columns. See that? Rows and columns are the same. So once we have equal rows and equal columns, we call those square matrix or 2 by 2 matrix. Sorry, 2 by 2 for 2 rows and 2 columns. Alright, so how we get our answer now? We add whatever is in row 1, column 1 to whatever is in row 1, column 1 of the next matrix. So let's look at 3 plus negative 7 gives us negative 4. So that goes in row 1, column 1 position. Now let's look at it now. Negative 2 is in row 1, column 2. So we're going to add it to the element in B that is also row 1, column 2. So that's going to be negative 2 plus positive 4, and that will give us positive 2. So we put that positive 2 in our row 1, column 2. Now we're looking at this one now. Straight line. So negative 5 is in row 2, column 1. So it's in row 2, column 1. And also in the matrix B, 0 is in row 2, column 1. So we can add it now. We're going to add negative 5 and 0, and that gives us negative 5. Then we have 6 is in row 2, column 2. And in the matrix B, we have negative 5 in row 2, column 2. Now 6 plus negative 5, that gives us positive 1. So the the matrix A plus B is equal to negative 4, 2, negative 5, positive 1. So which one matches? B matches. Alright, question 22. Same concept. Let's look back at it. Same concept. So you're going to use that same concept now and do question 22. Your turn now. Your example now. So tell me what to write and I'm going to write it. Alright, so we say set it out first. Alright. So we put in our P. So 3, negative 2, negative 5, 0. Alright, put a plus sign. Alright, put our Q. So 7, 4, 6, 8. Alright. So we can easily add them because they are both 2 by 2 matrices. So we can easily go ahead and add them. Alright, good. So then let's add them now, matching elements. So in row 1, and this is row 1, column 1. What is also in row 1, column 1 of the matrix Q? So therefore we're going to add 3 and 7 and we get 10. Then we're going to add the element in what? Row 1, column 2 to the element in row 1, column 2. So negative 2 plus positive 4, and that gives us positive 2. Then we have what now? We're going to add whatever is in row 2, column 1 to whatever is also in row 2, column 1. So negative 5 plus 6, and that gives us positive 1. And then we're going to add the last 2 elements. This is in row 2, column 2 to row 2, column 2. So 0 plus 8, that gives us 8. So our answer is going to be 10, 2, 1, 8. Positive, all numbers are positive, so our answer is going to be C. Alright, let's look at question 22. Alright, your try now. I'm going to take a pause. You're going to work out this question now and tell me how it goes. Alright, tell me what to write. And I'll write it. So we have what now? So the dot A minus B, so we have negative 7. Oh, sorry. Move too fast. So we have negative 7, 0, 2, negative 4, minus 1, negative 5, negative 6, positive 3. Now we can distribute this negative sign and we have negative 7, 2, 0, negative 4, plus, let's distribute the negative 7 we get now, negative 1, positive 5, positive 6, negative 3. And we can go ahead and add them now. So 7 plus negative 1, and that gives us negative 8. 2 plus 5, that gives us 7. 0 plus 6, that gives us 6. Negative 4 plus negative 3, that gives us negative 7. Or you could have easily just said negative 7 minus 1, that would give us negative 8. I could say 2 minus negative 5 gives us positive 7. So anyway you want to do it to the same thing. Alright, so the answer that match would be A. So our correct answer is going to be A. Let's look at question 24. Even though you see really well, who cares? Question 24. Alright, go ahead and tell me what you get. So we have, let's set them out. So we have P, negative 9, 1, negative 4, 0, minus 5, negative 3, 2, 7. So negative 9 minus 5, that gives us negative 14. 1 minus, so we have 1 minus negative 3, that gives us positive 4. And then we have negative 4 minus 2, that gives us negative 6. You can distribute or you don't have to distribute. So I'm just working it both ways so you can see that it works both ways. Alright, so 0 minus positive 7 gives us negative 7. So the answer that match, ding 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 ding, would be A. Alright, question 25. Now we're going to multiply our matrices. So we will add, subtract, then we're going to multiply our matrices. Now, before we can multiply our matrices, we have to check for our compatibility. Now, are they compatible? Now, the first thing is that the number of rows, so we have row by column, and we have row by column. So the number of columns in the first matrix must be equal to the number of rows in the second matrix. Let's go again. So you have a column, you have a row by column, you have a two matrices, right? Now the rule says in order for us to multiply them, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Now let's look at this matrix. The matrix P has the order. What's the order of the matrix P? We have 2 rows and 2 columns. So that's a 2 by 2 here. Let's look at the order of the matrix Q. Now we have 1, 2, we have 2 rows, and we have 1 column. Now we can see that what the number of columns in P is equal to the number of rows in Q. Hence, our final matrix is going to take the form of a 2 by 1. That means it's going to have 2 rows and 1 column. Get me? So the first thing we're going to check our compatibility. The number of columns in the first matrix must be equal to the number of rows in the second matrix. The other 2 parts were therefore, like the 2 here and the 1 here, our final answer is going to give us a 2 by 1 matrix. So the order of the matrix that we must get will give us a 2 by 1. 2 by 1 means 2 rows and 1 column. So immediately we could eliminate C, because C is 1 row and 2 column, and D is the same 1 row and 2 column. So we can immediately eliminate C and D. I'm looking for a 2 by 1. Now A and D are 2 by 1, but which one is the correct one? So let's look at how we go ahead and do the. Let's look at how we go ahead now and multiply. So we have 8, -3, 4, 0. Multiply by, calculating PQ. Multiply by -6, 2. Now, because we know our answer is going to be a 2 by 1, so that means that we're going to have A, row 1, column 1, and that means that we're going to have, or I can call it PQ, if we call it A, because the matrix is not A. Let me just erase that. Let's call it PQ, because the matrix that we want to find is PQ. So we have PQ. Let's call it PQ for the fun of it. So this is going to be the element that's going to be here is going to be in row 1, column 1, and the element is going to be here in row 2, column 1. Alright? Now we can multiply the elements and add them. So how we work this out now? So we're working out row 1 by column 1. So therefore, PQ, let me give it some space because I'm going to need this space to show the working out. So we're going to have 8 times -6 plus -3 times 2. That's going to give us the element for our PQ row 1, column 1. Then the element now for row 2, column 1, you're going to multiply 4 times -6 plus 0 times 2. So let's work out our PQ now. So 8 times -6, that's -48. So we have -48 plus 2 times -2, you get -6. Then we have 4 times 6, and that gives us 4 times -6, that's -24 plus 0. So we can add them now, -48 plus -6, and that gives us -54, and -24 plus 0 gives us -24. Alright, so our answer is going to be -54, -24. So the answer that matches is going to be A. So what I did, first thing, I check if the number of rows, the number of columns in the first matrix is equal to the number of rows in the second matrix. Once they are equal, then the matrices are compatible. Whatever is left on the outside tell us the order, or gives us the dimension of the new matrix. So in this case we had a 2 by 2 here and a 2 by 1. Sorry, 2 by 1. This is 1. This should be 1. Now because the 2 and these two are equal, then I automatically get a 2 by 1. Now a 2 by 1 means it has 2 rows and 1 column. So the element, we want to find the element that's going to be in row 1, column 1 and row 2, column 1. Let's try our next one. Try this one for me now. This one is also so let us test the compatibility of the matrices, because they have to be compatible before they can multiply. Alright? So we know that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So how much column this have? 1, 2. This have 2 columns. And how much row this have? 1, 2. This have 2 rows. So because them have 2 columns, 2 rows, that means that they are compatible, because the same number of columns equal to the same number of rows. So they are compatible. Now what would be the order or the dimension of the next matrix? Let's see. So 2 by 2 and a 2 by 1. Now because these two are equal, we're left with a 2 by 1. So the next matrix that will be formed will have 2 rows and 1 column. So go ahead and try. Look at what we did before and try. Try. So AB, so we have -7, 0, 4, -2, and then we have -3, -5. Let's multiply now. So what element will come here? Row 1, column 1. Let's multiply. Let's just call it AB, row 1, column 1, AB element that's going to be in row 2, column 1. So let's go now. So AB is equal to -7. So the first number multiplies the top number, and the second multiplies the bottom number. We add them. So -7 times -3 plus 4 times -5. Next one we're going to have the 0 and the -2 multiplied -3, -5. So 0 times -3 plus -2 times -5. When you realize that these numbers stay the same. So hence -3 times -7, we get +21. And this is going to give us plus -20. Still AB. And then we have 0 times -3. That gives us 0 plus 2 times 5 give us 10. So let's add them now. So we have AB is equal to 21 minus 20. That gives us 1. And 0 plus 10 is 10. So we get 110. So our answer that match is going to be B. Alright, let's look at 27. And now we're going to find the determinant of the matrix. You have entered the matrix, part 2. Alright, so how do we find the determinant of the matrix? I'll give you some notes here to refresh your memory. So the determinant of a 2 by 2 matrix of the form we have A, B, C, D is AD minus BC. Now AD is what we call the leading diagonal. So you find the product of the leading diagonal and subtract the product of the minor diagonal. That means that the other one is going to be the minor diagonal. Alright? So the leading one was a circle, that's AD, that's our leading diagonal. So let's follow the same pattern and find the determinant of P. Now we can write it as det P, or we can write it as the modulus P, same way. So in vectors we use this to mean the magnitude, and in matrices we use it for the determinant of the matrix. Alright? The determinant of the matrix, so leading, the product of our leading diagonal is 8 times 5 minus the product of the minor diagonal, which is going to be negative 3 times negative 9. So we know that 8 5s 40, and negative 3 times negative 9 gives us positive 20, so minus 27. So then we have 40 minus 27, and that gives us 13, positive 13. So hence our answer is going to be C. Alright, let's try it again. Imagine that light can start and can't start. Imagine the determinant of R. So we have R is equal to, so we have the product of the leading diagonal, so that's negative 7 times positive 2 minus the product of the minor, which is 4 times negative 8. So then we have negative 14 minus, and 4 times negative 8, that gives us negative 32. So that gives us negative 14 plus 32. Same thing as saying 32 minus 14, and that gives us positive 18. So C matches. So careful of your signs, because these questions testing if you realize the sign. Alright, question 29. Given that Q is negative 9, 4, negative 5, 2, then the adjoint of the matrix is, and I gave you some notes over here. So to find the adjoint of a matrix, we interchange the terms in the main diagonal. Remember, I showed you the main diagonal from before. Main diagonal. Let me show you it again. So why should I go back to flash? Extra? Yeah, I'm extra. When I grow up, I want to be not extra. Alright. So let's look at the adjoint now. Let's look at the adjoint. So interchange the terms in the main diagonal. This is our main diagonal. And then change the signs of the terms in the minor diagonal. So let's follow that instruction. So interchange it. So 2 of them go switch place. So 2, negative 9. Them switch place. Then it says change the sign. So that means that if it's positive, it will become negative 4. And if it's negative, it will become positive 5. So which one matches? We have 2, 5, A. So it matches to A. Alright. Let's look at number 30. Alright, so we find the adjoint where we interchange the terms in the main diagonal, so we interchange them. So we have negative 7, positive 8, and then we change the sign of the minor. So we have negative 3 and positive 6. And which one match? D. D matches. Alright, let's look at question 31. Alright, so we're back to vectors. So given the vector, I just pre-draw these triangles just so we can use them and draw upon them. So we give vector KL. So we start at K and we go into L. So KL is negative 4, 7. And then the next one is LM. Alright, so L M, so that means that we're going down to M. So here is M is 9, negative 2. What is Km? So from our diagram we can see that Km is equal to KL, tail to tail vectors, plus LM. So what is K? KL is negative 4, 7, plus LM, which is 9, negative 2. So negative 4 plus 9, that gives us, let me just rewrite this in a minute, that gives us positive 5. So negative 4 plus 9, positive 5, and 7 plus negative 2, same thing as saying 7 minus 2, that gives us 5. So the answer that match would be C. We're not that correct, but we can't bother for this. The matches can be brain and pronounce it properly. Alright, let's look at number 32. So we have given that the vector PQ, so starting at P. So these are displacement vectors. These are examples of displacement vectors. That means they can start anywhere in the coordinate plane, as opposed to the position vector that they start at the origin. So at O in the origin, alright? In the coordinate plane. So PQ is 8, negative 5. And QR, so that means where this end, this one starts, so I'm head to tail vector. So QR is negative 2, 1. Now, because I head to head tail, that means that PR, we want to find PR here. We can see that PR is going to be equal to the vector PQ plus QR. Where this one start, the other one end, and get the PR out the end. Alright, so therefore we get vector PR is equal to 8, negative 5, plus negative 2, 1. So 8 minus 2, that gives us positive 6. I almost say it right here, so negative 5 plus 1, that's negative 4. So our answer for the vector PR is 6, negative 4. 6, negative 4, and that matches to C. Alright, so this one says, given the points P and the points Q, then PQ is what? Now normally when you're given regular coordinates like this, we assume that we can represent them as position vectors. So we can write it as OP is equal to 1, negative 5, and OQ is equal to 8, 2. Now, because the origin is what? O, let's call here the origin O, 0, 0, and let's call here P. So this is going to be from O to P, let's say 1, negative 5. And then this one says OQ, so let's call here Q. So therefore OQ is equal to 8, 2. Now we can see clearly now that PQ is going to be OQ minus OP. Or you could do it as this. PQ is going to be PO plus OQ. Anyone you want to use the same thing. Just note briefly that we have OP, so therefore PO is going to be the inverse of it. Alright? So if you're using this one, consider that, remember that this is the inverse. So that means that if we're given OP, that means we're going to have -1, +5 for PO. Alright? And we can work both ways. Let's work both ways. Why not work both ways? So you can see it. So let me just clear it up. Give me like a minute. Alright, so PQ. What's our OQ? OQ is 8, 2 minus OP, and OP is going to give us 1. What? Why did I do that? Woo, woo, woo! Emergency, emergency! I attempted to write my vector as a fraction. Please do not, I repeat, do not make that error. Alright, so 8 minus 1, that's going to give us 7. And 2 minus -5, that gives us 7. So PQ is equal to 7, 7, and that matches to D. Now suppose we had used the same thing, what they have in common. So suppose we look at that and say, alright, we want to find PQ, the vector PQ. So therefore we go from P to O. So we're going in opposite direction, we have to reverse this. So PO and then OQ. So OQ direction stay the same. So therefore we could also say R PQ is equal to PO plus OQ. And background get extra quiet now because everybody turn off their music now. So they're going to hear all those Pennywise. I don't know what you call them in Antigua, I don't know what you call them in Trinidad or Barbados. Jamaica we call them Pennywise or cricket, they're annoying bad. But anyway, I'm straying. Alright, so PO now is going to be the opposite of OP. So we're going to have negative, say multiply it by negative now. So we get -1, +5 plus OQ, we're going to give 8, 2. So -1 plus +8, that gives us 7, and 5 plus 2 gives us 7. So you see we get the same thing. You just have to take in consideration that if you're going to work it this way, that you're working with the inverse of OP, which is PO. Alright? Let's try our next one now. Let's look at question 34. So we have R, the point R, -8, 2, and the point S, -3, 4. So find what RS is. So we can just write them as position vector in the column vector form. So we have OR, vector OR is -8, 2, and vector OS is -3, 4. You see that now? So because they both start at the origin, let's call here O. So OR, let's call here R. So OR will be -8, 2, and then OS, let's call here S. So OS will be -3, 4. Alright? So let's go, let's find RS. So RS is equal to OS minus OR. One little shortcut I give to my students them time over time, because for those who can't get it, just in your head, so the back minus the front. Alright? S minus the R. So the OS minus the OR. Please guys, not the concept what you get, just a quick way towards the answer for multiple choice. That's all. That's all. Don't care no way, don't tell nobody until just work it and move on with your life. Alright? So then we have, what's our OS? OS is -3, 4 minus OR -8, 2. So then we have -3 plus 8, and that gives us 5. And then we have 4 minus 2, that gives us 2. So we get 5, 2, and that gives us D. Or if we did say We extra over here. So we could say RS give us RO. Okay, we can do we can head to tail the vectors, head to tail. So RO plus OS. So that gives us RO will be the opposite, sorry, the inverse. So that will give us positive 8, negative 2 plus OS. Same OS give us negative 3, 4. So RS is equal to, vector RS is equal to 8 minus 3, 5. And negative 2 plus 4 give us 2. So we get our same 5, 2, which matches to D. Alright, so what we have 8i minus 3j, what we call this the component form. Call it the component form of the vector. Just some point. So if we have the point A, which is represented by xy, we can write it as a position vector, xy as the seat already, our column vector. And then now, the position vector OA is equal to xi. So any number that attached to I is our x, and any number attached to j is our y. Alright? So therefore we can write it as, so this would be our x, this would be our y. So therefore we're going to have 8, negative 3. So which one match? 8, negative 3, A. Alright, let's look at number 36, the same question. We say anything attached to our I is our x, anything attached to j is our y. So that's going to give us negative 9, positive 4. Which one match? That's going to be B. So remember this, we call it the component form of the vector, as the vector written in the component form. Alright. Question 37, we're getting there, we soon finish. Now these are some reminders, and you can screenshot it. I prefer if you write it down than to screenshot, because you know how screenshot work? Screenshot work like you copy it, you screenshot it and then you forget to in your screenshot, and then after exam, you say, what type of screenshot I have? Where did it come from? So it's better you write them down. I prefer you to write them down. When you write them down, that's one way for many persons to store things in their memory. For many persons, not everybody, to store things in their memory. Alright, so we have various transformations that can be represented by various different types of matrices. So we have a reflection in the x-axis is represented by that matrix 1, 0, 0, negative 1. And we have a reflection in the y-axis, which can be represented by negative 1, 0, 0, 1. We have a reflection in the line y equal x, so we have 0, 1, 1, 0. A reflection in the line y equal negative x, so 0, negative 1, negative 1, 0. If you realize the connection between this one and this one. And this one is in the interchange, the x and the y alright? And then you have a rotation anti-clockwise, you have 0, negative 1, 1, 0. 90 degrees clockwise, you have 0, 1, negative 1. So you realize that these interchange position. And then you have 180 degrees, whether it's clockwise or anti-clockwise, it's still the same thing. Negative 1, negative 1, 0, 0, negative 1. So just note these, write them down. Write them down. Don't screenshot it, write it down, write it down. Alright, and then we have the enlargement here, where we multiply it by a scale factor k and we get k, 0, 0, k. And we know k represents any scalar number. Alright, so let's look at the first question. Now the matrix 0, 1, 0, negative 1, sorry, 0, negative 1, negative 1, 0 represents, and you can go back to your table. When you go back to your table by comparison, negative 1, sorry, 0, negative 1, negative 1, 0 matches a reflection in the line y equal negative x, our answer is C. For this question, I'm going to put the table continually because it's something you're going to have to learn either by practicing or you can just swat it. Don't tell nobody to swat them still, but you can learn them still because we know them have the art, the cuts, and the sign and all that. They can work about name book, you know. Alright, let's go. And next video we can focus on that. Look at how they got all these transformations for the different matrices. You can work them out. I mean, them in your textbook. Alright, let's look at question 38. The matrix 3, 0, 0, 3. Obviously, this one is what? A scalar. So it's an enlargement of a scalar factor of 3 with the origin at 0. So look at it. Oh, and for the enlargement, this is the condition with the origin as center. For enlargement, we always have the center of enlargement. Alright. So for number 38, 3, 0, so this matches the enlargement of scale factor 3 with the origin as center. And for number 39, anybody remember this one? Negative 1, 0, 0, negative, sorry. Negative 1, 0, 0, 1 represents what? Let's look back at our table. And it matches which one? It matches a reflection in the y-axis. So this one matches to this one. A reflection in the y-axis, and that matches to D. And our last question, question 40. The matrix 0, negative 1, 1, 0 represents what? Let's see which one it matches with. And it matches with 90 degrees anti-clockwise rotation about the origin. So our answer for question 40 is A. And I believe that's all, folks. Leave your comments, subscribe, like. I'm also gonna have a video addressing some of the comments. Let's talk about the comments. Let's talk about the feedback. Let's talk about some of the misconceptions. Let's talk about some of the errors. Let's talk about some of the confusion. That's how we learn. All of we are learning. We are learning every day. So we are learning. Alright? All the best. Subscribe, like, tell a friend. And if you have already subscribed, thank you very much. Thank you very much for your support.